All right, welcome everybody. Now we're going to talk about Chapter 3, Section 3, Analyzing Graphs of Quadratic Functions. Okay, remember a quadratic equation looks like this. Y equals ax squared plus bx plus c. And if we set it equal to 0, we have what's called in standard form. All right, so what we're looking at now is the graphs of these quadratic equations. Remember, when we first talked about in Chapter 1, we talked about linear equations. Linear equations where the first term, this one's gone, we have bx plus c, where the m represented the slope and the b represents the y-intercept. So if we were to graph that one, we'd graph the y-intercept first, set -2, and then follow the slope up 2 over 3, and then connect the dots. So that was pretty easy when we do linear equations. But now, quadratic equations aren't so straightforward. It's a curve. And the bottom, since it is a curve, it has a low point or a high point, depending on where it's going. And that low point is called the vertex. Okay, and we can tell a lot about this equation by looking at two parts. The first part and the constant part. The constant part of any equation, actually, I don't care how big or how small it is, the number by itself, no x's, is always your y-intercept. And whatever the first part is, the one with the highest exponent, that's called your leading term. The leading term is made up of two parts. The number in front is called the leading coefficient. And then you have the variable part. But the exponent of the variable is called the degree. And that tells us a lot. For example, in a quadratic equation, we can tell what the graph's going to look like just by looking at the leading term. So we have the leading term here, where that n is the degree. You have to make sure in your equation it's the largest exponent. Okay, if the degree is odd or even, that's what it'll be on. Look at the top row, and the leading coefficient, if it's positive or negative. But we know for sure that a cannot equal 0 in quadratic equations, because if it's not quadratic, if a is 0, then we get a linear equation, so it doesn't help us much. All right, so if a is positive and n, this is your n, your degree, if n is even, then we know that the two ends of your equation go opposite direction, and it's going to the right, it's going up, since a is positive. If the degree is odd and a is negative, then both ends go opposite directions, and the left side goes up, right side goes down. It's a decreasing function. If your degree is even and a is positive, that means both ends of the function point in the same direction. They both point up. And what happens in the middle, we don't know. And if a is negative and n is even, we know both ends point in the same direction. They both point down. So odd degrees, opposite directions. Even degrees, same direction, either up or down. We call that end behavior. So for example, if I gave you this equation, negative 3x squared, or x cubed, plus 2x squared minus 5x plus 1, by looking at the leading term and the constant, we have a good idea what this graph's going to look like. We know we have a y-intercept at 1. And we know since the degree is odd, the ends point opposite directions. And since a is negative, it's decreasing. So whatever your farthest left x-intercept is, it goes up, and whatever your farthest right x-intercept, it goes down because it's negative. Right? So now, since the section deals with graphing, to graph a quadratic equation in standard form. Remember, quadratic equation is ax squared plus bx plus c. Standard form is equal to 0. So for example, if we had y equals x squared plus 5x plus 6, that's a quadratic equation. To graph it, what do we need? We need the x-intercepts. Remember, since the degree is 2, we'll have at most 2 x-intercepts. We need the y-intercept, and that's always the constant. We need something called the vertex. We remember that's the lowest or the highest point. And we need a few points to continue the graph. So remember, the degree is important of the leading term. Let's look at the degree. Tells us the maximum number of x-intercepts possible. Then we have the constant term back there. It tells us the y-intercept. So let's review the what the leading term tells us. So we have the degree. We have either a max or a min. Remember, the degree is the exponent of the largest exponent of your function. The degree is either even or odd. If it's even, remember, if it's even, the graph will point up. So we're going to have a minimum function. And we don't have any maximums. If it's odd, if the degree is odd, then we don't have any in there, and we don't have any min either. Because a degree being even, it'll look like this. Odd, it'll look like this. So we don't have any maximum or absolute maximum. We'll talk about those in a little bit. And evens, if the degree is even, then we have a minimum if it's even. If it's odd, then we don't have any. So let's look at why is that so? If n is even, so let's say we have n is 2. The graph can look like this. The graph can look like this. Or the graph can look like this. Notice we can have 2 solutions. We can have 1 solution or no solutions. If n is 4, our graph can look like this, meaning we have 4 solutions. It could look like this. We have 3 solutions. We have 2 solutions. We have 1 solution. Or we have no solutions. And likewise, if it's 6, we can have 1, 2, 3, 4, 5, 6 solutions, all the way down to no solutions. If n is odd, let's say n is 1, then we have a linear equation. We have 1 solution. If n is 3, we can have 3 solutions. We can have 2 solutions. We can have 1 solution. Now, we go back over here then. Let's redefine this. If n is even, the most number of solutions you can have, this is what we talked about for that, but now we're going to relate it to these. If your degree is even, it's 2, 4, 6, 8. The most numbers of answers you can get is whatever n is. It could be 2, 4, 6, 8, whatever. The minimum you can have are 0 solutions. It could be off the graph. If it's odd, the most you can have is n number. So if n is 3, you can have 3. If n is 5, you can have 5 as most. But the least number of intercepts you can have is 1. Because if n is odd, since they go opposite direction, there has to be one place where it crosses the x-axis. All right, let's look at this example. Y equals x squared plus 5x plus 6. Again, since we know it's a quadratic, we know the graph will look like this. And since the leading coefficient is positive, it goes up. So how do we find the x-intercepts? Remember last section, we could do it by factoring. So we have to set it in standard form first. We could do it by factoring. If it's factorable, x and x, look at the second sign. It's a positive, so that means there's same signs. It's whatever the first sign is. And then to find the numbers, take a times c, which is 1 times 6 equals 6. Then figure out two numbers that multiply to equal 6. That when you, whatever that sign is, when you add them, you get the middle number. So 3 times 2 is 6, 3 plus 2 is 5, and it doesn't matter where they go. Then I set them both equal to 0. So x is equal to -3, x equals to -2. Those are my solutions. We could do complete the square. For complete the square, remember, it has to be in standard form. And the leading term has to be 1. So first step, move the constant term. Then we have to add b over 2 squared to both sides, and b is whatever is in front of the x. So we have b over 2 squared. Okay, since we can't do anything inside, on the left side, we can only do what's inside the parenthesis. On the right side, we have to work it all the way out. So this side, since we can't do anything, take the first term. Whatever's under the squared goes inside this parenthesis. Take the first sign and whatever's in the second one. So that's -6 plus 5 squared is 25 over 4. This is over 1, so we have to get common denominators. So this one needs 4 over 4, which is -24 over 4 plus 25 over 4 equals 1/4. Square root both sides. We get x plus 5 over 2 equals plus or minus square root of 1 is 1, square root of 4 is 2. We move that over. So x can equal to -5 over 2 plus or minus 1/2. Plus 1/2, -5 over 2 minus 1/2. -5 plus 1 is -4. -5 minus 1 is -6. So it's -2 and -3. Same thing we got earlier. Or we can do the quadratic formula, which was this formula. -b plus or minus square root of b squared minus 4ac over 2a. Label A, B, and C. A is 1, B is 5, and C is 6. And plug them in there. We get the same thing. All right, so All right, so that's the first way we could do it. We could do those ways. Remember in the quadratic formula, we had negative b plus or minus square root of b squared minus 4ac 2a. This number inside here was pretty important because it told us how many answers we're going to get. How many real solutions? Because if it was positive, we'd have a plus or minus, so it's two possibles. If it's 0, then it's just negative b over 2a. If it's negative, we're going to have no real solutions because they'll be imaginary. That was called the discriminant. And it came from our coefficients of this equation. So that's where we found the x-intercepts. So again, review this. The discriminant tells us the number of real solutions. Because if b squared minus 4ac was positive, then we'd have two solutions. Those are our two solutions. If b squared minus 4ac equals 0, that means we only have one solution. And that solution is called the vertex. If b squared minus 4ac was less than 0, then we have 0 real solutions, which means our graph looks up like that. So the question is, how do we find the vertex? The vertex formula, it's a point. The vertex is a point. Since we know the vertex comes whenever we have b squared minus 4ac equals 0, which means this part is 0, that means the x value of the vertex is equal to negative b over 2a. And then once we have the x value, plug that back into the original equation, and that'll tell you the y value. Remember, this is the f of x. So whatever that becomes goes in place here inside the function. So let's look at in our example. We had y equals x squared plus 5x plus 6. First thing we gotta do is label our a, b, and c. So to find our vertex, we need our x value. The x value was negative b over 2a. If you ever forget, that's just the front part of the quadratic formula. No square root. Let's plug those in this. We have negative 5 over 2 times 1. So x equals negative 5 over 2. That's our answer for the x value. So it's negative 5 over 2. Now what we have to do, back to our original equation, anywhere we see an x, we got to put negative 5 over 2. So negative 5 over 2 squared plus 5, negative 5 over 2, plus 6. These are fractions. Okay, in this first one, because we're using the distributivity rule also. If we have a fraction raised to a power, then that power goes to both top and bottom. So negative 5 squared is 25. 2 squared is 4. Positive times negative is negative. 5 times 5 is 25. 1 times 2 is 2. Plus 6. Now we have to get a common denominator. These are all fractions. So the smallest denominator that they all fit into is 4, which means this one needs to be multiplied by 2, and this one by 4. So we get 25 over 4. 25 times 2 is 50. 2 times 2 is 4. 6 times 4 is 24. 1 times 4 is 4. Got a common denominator, so we have 25 minus 50 plus 24. 24 plus 25 is 49 minus 50, and that equals negative 1 over 4. So the y value of my vertex is at negative 1 over 4. And there's my vertex. All right, so let's go ahead and graph this function now. We have all the pieces we need. So graph the function y equals x squared plus 5x plus 6. From the other side, we knew our x-intercepts were negative 2, negative 3. The y-intercept is 6, and the vertex was negative 5 over 2, negative 1 over 4. And because it's a quadratic equation, positive, we know the graph will look something like this. All right. So let's see. We have x-intercepts at negative 2 and negative 3. The y-intercept at 6, 2, 3, 4, 5, 6. And the vertex is at negative 5 over 2, which negative 5 over 2 is 2.5, or 2 and 1/2. So it's between negative 2 and 3. And it's negative 1/4, which is there. That's negative 1. Okay, so we found our x-intercepts, the y-intercept, the vertex. Now we need another point. Because quadratic equations are symmetric, they're symmetric about this point here, the vertex. This line through the x value of the vertex is called the axis of symmetry. the vertical line going through the x value of the vertex. So what that means is the right-hand side and left side are equal. That's what I see. From this point, there's half a point there, half a point there. Those 2 points are equal. So likewise, if since it's symmetric, if we go from 1, 2 to the right and up 6, we have that point. So from this one, if we go 1, 2 and up 6, we have another point that's symmetric. Connect the dots. And that's our graph. So like for the axis of symmetry of this equation is x equals -5/2. It's the x value of that line, of that vertex. All right, so let's look at the examples.